Here we're going to look at example 1, solve quadratic equations from section 2.6, the quadratic formula. So our objective really is to use the quadratic formula to solve equations that could potentially have complex solutions. So in problem A, we have 3x squared minus 4x minus 9 equals 0. And because I know what is going to happen and we're using the quadratic formula, before I introduce the quadratic formula, since I know I'm using it, I'm going to label my A, B, and C values from my equation. So in this case, that 3 is our A, negative 4 would be our B value, and then negative 9 is our C value. So using the quadratic formula, the actual quadratic formula itself would be x is equal to negative b plus or minus b squared minus 4ac over 2a. Now, one thing to keep in mind here is that a cannot be equal to 0, but if a is equal to 0, this isn't a quadratic anyway, so you wouldn't use the quadratic formula on something that is not a quadratic. But either way, let's plug in our values and then simplify our expression. So x is equal to negative. Be careful with your signs, and I highly recommend, and it's almost not even optional, anytime you're substituting, you should really be using parentheses for these type of problems. So b squared, that would be negative 4 squared minus 4 times 3 times negative 9, and all of that would be over 2 times 3. All right, so some quick highlighting, right? These b value, nope, that's not the b value, sorry about that. The b value is going to be this 2. The a value is used in both the numerator and the denominator, and then the c value, which is in pink, is going to be used once in the numerator. Continue from here. Be careful with your signs. So the first piece here, we have negative 4, so that's going to be a positive 4, plus or minus. Be very careful typing things into a calculator. Negative 4 squared, you need those parentheses because you're squaring the negative 4. That's going to be a positive 16. If you did not put those parentheses in the calculator, it's going to return negative 16. That's not what we want. And then negative 4 or minus 4 times 3 times 9, or negative 9. So 4 times 3 times negative 9. So this is going to be a positive 108. Now, that is probably the area, and that denominator is going to be 6. But going back to this piece here, this is probably the most common mistake in these problems because of the subtraction or the negative signs. So just always keep that in mind. Take your time with that. For this specific problem, you have a negative and a negative, so you should know that when you're multiplying those two negatives will make that a positive. So please be careful there. All right, let's continue simplifying this. So x would be equal to 4 plus or minus 16 plus 108 is going to be 124 over 6. Sometimes you're done here, most times you are not. You do need to look to see if you can simplify this and if part of that can come outside of the radical. In this case, sometimes it's trial by error, sometimes it's just being really familiar with the numbers, but you want to test perfect squares. So you want to see if numbers like 4, 9, 16, 25 go into that. What's going to happen is 124 is 4 times 31. So I'm going to split that up. And that's all still over 6. So x would be equal to 4 plus or minus. I can now take the square root of the 4, which will come out as a 2, and then the 31 would remain inside. Again, a lot of times you're done here. However, in this specific problem, these three numbers all have a common, greatest common factor. 2 goes into all of them. So I'm going to reduce this expression to become 2 plus or minus. That'll stay, that 2 would divide out. Radical 31 over 3. All right, so each of those, the 4, the 2, the 6, were each divided by 2. and then this would be our solution. You have two solutions here, right? We have a plus and a minus. So you can write it as that one solution, or if you wanted to, you could write this as x is equal to 2 plus radical 31 over 3, and x is equal to 2 minus radical 31 over 3. So just keep it in mind here that there are two solutions when you have that plus minus, and those two solutions will be written on that right there. All right, part B, we're doing the same thing. All right, it's just extra practice with the quadratic formula. So I'm going to rewrite the equation. I'm going to label my A, B, and C. So A in this case is 21, what am I saying? A in this case is 1. There's a 1 out there. Don't forget that. So let's highlight again. So A would be equal to 1. B is equal to negative 9. And C is equal to 27. So writing out our quadratic formula, x is equal to negative b plus or minus b squared minus 4ac over 2a. Once again, when you're substituting, make sure that you are putting these numbers in parentheses. It's going to help avoid a lot of mistakes down the line. So we have negative 9 squared minus 4 times 1 times 27. And all of that would be over 2 times 1. Right, so simplify what we can. X is equal to 9 plus or minus negative 9 squared would be 81. We have a subtraction sign, so there's really only one negative here, so it's going to stay as a subtraction or a minus. 4 times 1 times 27 is 108, and then all of that would be over 2. So let's continue. X is equal to 9 plus or minus 81 minus 108 is negative 27 over 2. Same as before, inside the radical we need to check to see if we can reduce this. Because there's a negative there, I know at least I'm going to be able to take out the imaginary number I. So let's rewrite this. Before I take anything out, I like to rewrite this in simpler terms, what I know I'm going to break down. 27 is the same as 9 times 3. And the reason I'm using a 9 there is because it's a perfect square. So that's going to be, part of it is going to be taken out. So x is equal to 9 plus or minus 3i radical 3, and all of that will be over 2. Now that negative 1 came outside as an I, and that 9 came outside as a 3. The other 3 remained inside because we can't take the square root of 3. Can't reduce this one, the 9, the 3, and the 2. These 3, the 9, the 3, and the 2 do not have anything in common, so we'll leave that as is. And then same as before, we can write that as one group. It's two solutions, or you could write that as x is equal to 9 plus 3i radical 3 over 2, and x is equal to 9 minus 3i. 9 minus 3i radical 3 over 2. Either way will work. Just know that there's two solutions. Both of them are imaginary or complex solutions, whereas in part A you had two real solutions. Okay. So with these problems, the nice thing about the quadratic formula is that it always works. It does get a little messy, and there are some opportunities where it's very easy to make a mistake. So use parentheses. Don't try to skip steps. Don't try to take shortcuts with these. Just work them out. The quadratic formula, again, you can always use it as long as there's a quadratic. You use the quadratic formula. It will always give you the answers. Just take your time. Be careful with your work. Be careful with your signs. And be careful breaking down any radicals.